Okay, so this section, section 5, is dealing with something called rational expressions. Move this a little bit here. All right, there we go. So a rational expression is a fraction. Rational means fraction, basically, in math. And it's a fraction that involves polynomials. So an example of a rational expression might be x squared plus x minus 6 over x squared minus 9. So this is what's called a rational expression. And so the goal in chapter 5 is to do our kind of basic operations with these rational expressions. So those are things like simplifying it, adding, subtracting, multiplying, dividing, and then finally solving some equations like the question that was asked in the beginning. So we're going to want to do all of those different things with this kind of new type of expression, this rational expression. And I will tell you here in the beginning that the challenge for students is, strangely enough, it's not actually the skills. With a little bit of work, kind of everybody figures out how to do these different types of problems, but people always make mistakes about which kind of problems they're supposed to do which kind of skills with. Okay, so when we're teaching these and looking at these and doing our homework, we really want to be conscious of identifying the type of problem and then making sure we're doing the right skill with that type of problem. Okay, and that'll become more clear, hopefully, as I go through a couple of these examples. The first rule here for all rational expressions, rule number 1. Factor first. I'll even put that like little stars around that. That's how important that is. I'm not a kind of star person in general, but there are times. So if you factor these problems first, you will be starting in the right road no matter which type of problem it is. If you don't factor it first, typically the first thing you do is wrong, and then everything else is wrong after that, and you're going to end up with very few points on any of the problems. So with this one, we want to factor it first. I know some of you might be thinking, oh, there's an x squared on the top and an x squared on the bottom, so I can cancel those, and that is wrong. You cannot do anything like that until it's factored. Luckily, you've been practicing factoring, and I did just finish grading your take-home work from the previous section. Sorry that it took me so long, nearly a week, but I did finish grading it, and the factoring overall looked quite good. So I have confidence you'll be able to do it as long as you choose to do that first. So the first one is a trinomial. It ends up to be x plus 3 and x minus 2. And I'll factor these relatively quickly. I know on your own it may take you a couple tries perhaps, right, to get the right pattern. The bottom is a perfect square, and that one factors nicely, and hopefully those you find go quickly. So number 1 rule is we're going to factor these first. And then we're going to think about what we're doing with the problem. So this problem here, and I didn't write out the instructions in the beginning because, again, I wanted you to focus on the factoring. But the instructions, all we could do with this is we could simplify. There aren't two expressions to add or subtract or multiply and divide. It's just one thing. So all I can do with one thing is simplify it. And now that it's factored, these are common factors. There's an x plus 3 and an x plus 3, and that's probably what everyone wants to do. And that's now the right thing to do, right? Now that it's factored. So this gives me an x minus 2 and an x minus 3. You've got to view these as different things. They cannot be canceled. Can't cancel the x's there because it's not x, it's x minus 2. And that's a different number than x minus 3. You have to do the adding or subtracting before you can do any canceling, and that's going to change these. Here, because it's multiplication, factored, I can cancel anything but that's the same between the top and the bottom. Okay. Now, again, I know probably some of you that you understand that already, but I'm going after those of us who are just a little shaky on these. These are a type of problem where I see students really diverge, and we want everyone to be doing well in the problems. If you don't do well or see them the wrong way, they kind of all go south on you, and we want to make sure we stay away from that. Okay, so to simplify.
Oh, sorry. I
Go
have a
ahead.
question.
Yes, jump in, please do.
Is that homework number 5, number 1, or you just randomly just gonna problem?
I just made this one up. It could definitely match some other problems, but it's not the one from the take-home work.
Okay.
There probably is one in the take-home work that is probably very similar to this. But the take-home work, I mixed up all the problems in different order. So to make sure that you're seeing them and choosing the right strategy on them. So yes, this is just an arbitrary simplification problem. And I will say, when I or the book makes up these simplification problems, we really always make them so something cancels. It wouldn't actually have to. I mean, sometimes the expression is already simplified and there's nothing you can do. But it's not a very interesting question that way, or it's hard to know if the student did it right or wrong. So you can always look for something to factor, something to cancel once you factor. If for some reason nothing cancels, you might want to go back and say, did I factor that right to start with? Okay. We'll come back to some of these.
I have a quick question.
Yes, please.
Is simplifying like rule number 2 or?
So simplifying, think of it as like, there really is no rule number 2, actually. It's all rule number 1, which is factor first. Everything else is then specific to the type of problem that we're doing. So whatever the rational expression is, I'm going to factor it first. After that, I might simplify it, or I might have to add it or multiply it or do other things with it. So that will depend on the type of problem. So with simplification here, once it's factored, all we do is cancel common factors. So if you want to say, like, for simplify, what we're going to do is we're going to cancel common factors. So yeah, I mean, you could call that a rule, I guess, but it's really just like a description of what we're trying to do. And again, this becomes tricky because we keep adding, we're going to add like a couple more operations. I used to teach this, and I used to like work really hard on simplification and do a whole bunch of examples of simplification. And then I'd move to multiplication, and I do a whole bunch of examples of multiplication. And then by the time I got to the next one, people would be so locked in with the previous ones that they couldn't switch and do the other versions. So now I teach it by kind of showing all the different types in the beginning and then kind of going back and working through each of those different types. So with that idea, let's try this example. 4x over x squared plus 2x times x squared minus 4 over 2x squared plus 6x. Okay, so what do we do?
Factor first.
Factor first. Excellent idea. Rule number one, right, is let's not even worry about what we're doing. Let's just factor this down. We need to see the individual pieces so we can then know what to do with them. Now, it does turn out this is a multiplication problem, so I would have to tell you, what you're trying to do, which is to multiply. But it turns out that's not important. What I need to do is factor it. So the top here is already factored. That's fine. The bottom, be careful with these. These are fairly common in the problem. They look like they might factor like one of these, but they're really just a GCF. They're actually like easier to factor if you see that. We try and save you at least a little bit of effort on factoring, just because we don't want you to eat up kind of all of your time and energy on the factoring part. And then here I can pull a 2x out. So there's no reason I couldn't give you, a bunch of trinomials. You're capable of doing that. It just turns it into a kind of longer problem than we'd like. All right, so now that it's factored, what we have to do here is multiply. And I want you to remember that these are really fractions. So when you multiply fractions, you actually just multiply straight across. It's the easiest operation that we have with fractions. I'll write it out here. I get 4. Yep.
Do you cross out the like?
Yes, I will. And you would probably want to do that even before I'm writing out this step. This is kind of an extra step that adds a little extra work. Because what happens is when you multiply straight across, each little piece in the tops is all on the top, right? And each piece on the bottom is all on the bottom. So you might as well just cancel out those common factors because it's already factored, right? You can just cancel out the common factors even before you do the multiplication. So since I've written it out, I'll do it from here, but the x plus 2's cancel. One of the x's cancel, because remember that's 4 times x. And the 2 also divides there into the 4. And so if I kept track of all of my parts, I have a 2 and an x minus 2 on the top, and I have an x and an x plus 3 on the bottom. And again, I would probably encourage you right from this step to do your canceling. It doesn't matter about going across. It only matters between the top and the bottom, right? So this x here cancels with this x there. This x plus 2 cancels with that x plus 2, and that 2 cancels there. And that's going to give the same answer either way. There's no need to multiply this back together. That's not helping us. It's not wrong, but it's extra work that we don't need to do.
I have a question.
Great.
So normally negative and positive cancel each other out, right?
When you're adding, a negative and a positive cancel each other out, like 2 plus minus 2, right? Give us just 0. But when you're multiplying, it's actually the reciprocal. So 2 times 1/2, right? Those cancel each other out or neutralize each other. So that's actually what's happening here when I cancel between the top and the bottom. It's the same idea as this, that the reciprocals cancel each other out when you're doing multiplication. Does that
Okay.
Does that make sense?
Yeah.
It's all of these problems really behave the same way that fractions do. But of course, it's much harder to see that here because they're all these x's and numbers and pieces. But it's really no different than if I wrote, 2 times 3 over 5 times 7 times, 5 times 2 over 3. Like this is a fraction of numbers multiplied together. It's the same thing here, right? Like these are all factors, and I get to cancel any factors that are the same between the top and the bottom. And then I just multiply straight across 2 times 2 over 7. So if you can see it that way, then at least it feels hopefully like something you've done before. But you don't really have to think about this because it does. I think for many students, it feels different just because of all the x plus 3s and x minus 2s and things. So what I say with multiplication is actually really the same as simplification. Like this is not very different from the first problem we did, right? It's factoring, and then it's canceling common factors. I mean, there's more of them, I guess, because I'm multiplying, but fundamentally, it's actually the same process as the one up above, right? I'm canceling the same factors between the top and the bottom. So I like to group multiplication as really the same goal here. So to simplify, I was canceling common factors. And really, when I do multiplication, I'm also canceling common factors. Okay. Other questions? And I love it when you guys jump in. Really, I mean, just hop right in with any question you see about anything. I'm happy to. I'm much happier to be interrupted slightly, right, than just talking to myself. Okay. Anything else? Does it feel, can you see or feel that these are kind of the same things, like simplifying and multiplying? I mean, they are different operations, of course, but simplifying is one thing and multiplying is two things, but it really does just come down to canceling common factors. And it turns out that division is almost the same, right? If you remember with fractions, 2/3 divided by 6/5. Division is just where you multiply by the reciprocal. Reciprocal. And multiplication is, we just did multiplication. So division, it actually turns out is really in the same category of problems. Division is maybe, we'll write that in there, but flip and cancel common factors. X times x plus 2 over x plus 3 times x minus 1 divided by x squared minus 9 over 4x. I kind of partially factored it to save us some time. But here, you just have to take an extra step to rewrite it by flipping what you're dividing by, turning that into its reciprocal. And because I'm slightly lazy, I don't want to rewrite it and then rewrite it again and factor it. I really want to try and combine those steps. So as I flip it, I factor it as well. And I think that's worthwhile because otherwise you got to write this whole thing out again and it starts to get tiring. Oh, and I have to make sure I factor correctly. I'm always, I mean, I'll tell you, even I, right? I'm always checking my factoring, right? So I looked and I was like, oh, wait, if I multiply that, I'm not going to get what I started. That's fine. You'll make lots of little mistakes, but you can also catch all those mistakes. So here, well, I didn't write a very good question, right? Because notice what happens here. It looks like nothing, right? It doesn't appear I can do any canceling, and that's okay, I guess, right? I would say normally that probably means something went slightly wrong. For me, I guess that just means I didn't write a great problem there. Right, there's x plus 3 times x plus 3, so I can write that x plus 3 squared. So in this case, no simplification, but I think you hopefully get the idea, right? Once you flip it, it's the same as the previous problems. Okay. Questions? All right. We're gonna charge ahead here. So like I said, I'm gonna
If you were multiplying across, wouldn't it be 4x squared? Like, are you multiplying the 4x with the x?
That's right. I'm grouping those together just because it makes it a little easier to write. I'm not distributing, so I'm not multiplying the 4x times both of these. It's all multiplication, so I'm just picking the 4x times whichever one I want.
So would it be like the x that is outside the parenthesis is what you're,
That's exactly right. So these two x's I'm multiplying together to get me the x squared. And then I have a 4. And then I have an x plus 2. So on the bottom, I multiplied the two x plus 3's together to get the squared. And then I also have these other two factors. Too many lines there. Does that help? Is that? I mean, you could write this 4x times x plus 2. There's nothing wrong with that. That's also a good answer. When I multiply those together, I have a 4 and an x and another x and an x plus 2. I mean, you could also write it x times x plus 2 times 4 times x. That is also the same thing. Right? You can do that multiplication in any order you want. Any other questions on that process? Okay. So our next step is addition. Normally we do addition before multiplication, but it turns out that multiplication is actually easier than addition, so we save that for later, which is right now. And let's do 2/15 plus 7/10. So just so you remember, when you're trying to add fractions together, and these are fractions, you need common denominators. And you may have different ways of figuring out common denominators that work great for numbers, and that's totally fine. What I like to do is I like to factor the denominators. And then I like to bring in any missing factors, right? I need the same denominator. Here I have a 3 and a 5, and over here I have a 2 and a 5. So if I have a 2 here, I got to have a factor of 2 over on this one as well. And now this one has a 2 and a 5 in it, so that's good. This one needs a 3, right, to match this one over here. So I do that by multiplying top and bottom by 3. So this process here that I've done in blue to emphasize that it is something new, this is creating common denominators. And that's the necessary step when we have addition. Right? It's some extra work for us, but we need to do that. So what that gives me is 4 over 2 times 3 times 5. And then this is going to be 21 over 2 times 3 times 5, right? I can write those in either order. And so now that they're the same denominator, I get to add them together. 25 over 2 times 3 times 5. And then finally, we can do a little simplification. Right here, one of the factors of 5 cancel. Or 5/6. So we're going to do the same process with polynomials now. Try and keep this on the screen so we can see. Let's see both. Maybe. Let's try 2 over x squared plus 4x plus 3 over x squared minus 16. Now, I shouldn't have to tell you, but I would. This is an addition problem, right? I'm trying to add these two together because of the plus sign there. So if I'm adding, what do I do?
Find a common denominator.
I do, and in order to find a common denominator, that's exactly the right statement, and you've got to kind of build that in where you say that to yourself, because I'm not going to be there to say that to you all the time, right? When you're adding, find a common denominator. If you think that way, you have a very good chance of getting this problem right, or at worst, mostly right, which is pretty good too. Okay, I'm a fan, even in math, of being mostly right. So if you don't come up with a common denominator, you're going to be mostly or probably completely wrong, which is also something we want to avoid, right? So big difference there. Common denominator. To get a common denominator, what do I need to do?
Factor.
Excellent answer. That's also a pretty safe answer with these rational expressions. I want to factor. The difference here is I am not factoring to cancel. That was a simplifying or multiplying or dividing. I'm factoring to cancel, right? But here I'm factoring to do this blue step, get that common denominator. So I get x times x plus 4, and I get 3 over x plus 4 times x minus 4. Rule number 1, there is only one rule, right? Factor. Okay, so now I'm trying to do this so it's kind of a parallel operation here. Now I'm going to create the common denominators. When I look at this bottom one, I see I'm missing an x minus 4. I can't turn the x into an x minus 4. X is different than x minus 4, but I can get an x minus 4 in both of those. And over here, what do I need? Let's see it. I'm gonna give it away. X. I think you might have known that, but it's kind of effort, right, to unmute yourself and jump in. So that's an X. Do you guys see that? That those are the missing factors that turn both of these denominators into the same three factors. They all now have an X minus 4, an X, and an X plus 4. So my next step is to multiply these numerators together so that I can add them. Do not, I will see a lot of students, go ahead.
I thought if it's like that and you times the left side x minus 4, won't you times the right side x plus 4?
Only, so the way I'm keeping this balanced, this isn't an equation, so I don't need to do things to both sides, but if I do something to the bottom, I've got to do the same thing to the top. So that's the way that I kind of keep it balanced. I don't change the fraction by doing the same thing to the bottom and the top. So over here, this side already had an X plus 4 in the denominator. So I don't need another X plus 4. This side has an X plus 4 too, right? But that's fine. I already have it on this side. What I'm missing is this one, the X minus 4. So that's why I multiplied top and bottom by X minus 4.
Okay, but then how do you minus the right side just with just x?
So when I look at this denominator here that I've got, I see three factors. I've got an X minus 4, an X, and an X plus 4. Three things. This side, before I did this, had only the X plus 4 and the X minus 4. Only two. So I need to add in that missing factor, which is that X. So now if I look at each of these denominators, they are exactly the same. They all have the same three factors. Does that?
So you times the right side with just the x that's missing.
That's
Okay.
that's right. I mean, like technically what you could do as well, and the book may explain it this way, is like you might look at these two denominators and we might teach you to find the least common denominator. There's like a process to find the least common denominator, and then you can turn both of them into the least common denominator. But to me, that's like an extra step that it's kind of not necessary, I guess. So I try and teach it this way, as a way of kind of creating the least common denominator without even really thinking about what it is. And that's how I do it with the numbers too. Like some of you might look at 15 and 10 and just kind of know that 30 is the least common denominator, but you don't even really need to do that if you just focus on keeping track of the factors. And that works even better when we have polynomials, because it's hard to see it. Like I can't see what polynomial is the same there. I have to look at the individual factors and make sure they match up. So let me finish this one and I'll do another similar example, and maybe hopefully that'll help clarify. My next step here is I've got to multiply these out. Do not make the mistake of canceling the X minus 4. I see that a lot. And it's like, but you just put it in there. You don't want to cancel it back out, right? It was like a bunch of work to put it in there. We need that X minus 4 in the bottom, so we also have to have it in the top. I've got to just multiply out whatever that is. And that. And at this point, you could just put it all over the one denominator, but maybe it helps here to just write these out kind of all the way. I just reorder them just because I like to put the the single terms in the front and the binomials in the back, but it doesn't matter what order you write those in. The key thing is I've created a common denominator now, so I can add these numerators together. So 2x minus 8 plus 3x, that's 5x minus 8. And it just goes over this common denominator. I'd simplify if I could, but there's 5x, there's nothing to factor here, and this 5x minus 8 doesn't match with any of these. So I think you can probably see why we save the addition, right? It is harder. I'm not gonna lie or pretend it's not. It is harder because there's this extra step. But it's manageable. We just have to keep track of what we're trying to do with it. Questions about this? I'll do another example. But any questions here? All right, let's try 2x over x squared plus 7x plus 12 minus 5 over x squared plus 3x. It's actually pretty similar to the last one, but that's okay. Now, you should notice that this is subtraction, not addition. Turns out subtraction and addition are very similar in the same way that multiplication and division are very similar to one another. It's the same process. We need common denominators. The only difference is rather than adding the numerators together, I'm going to subtract the numerators, right? But really, it's the same problem. So just like before, we want to say to ourselves, this is a common denominator problem. I need to find common denominators, and I'm going to do that by factoring. I'm actually not that worried about, oops, sorry. I'm not that worried about the numerators here. There typically aren't anything. Excuse me. There typically isn't anything that I can actually factor in the numerator anyway. But even if there was, it turns out we don't really want to factor those. It doesn't help or hurt because I'm very focused on the denominators. You see in this case, it's really similar, but I'll tell you a lot of the problems are this kind of similar in that there's almost always a shared factor between the two denominators, especially when there's several factors there. What that does is it means I don't need as much to make a common denominator. So when I look at the left side, I'm like, it doesn't matter which side I look at first. So I just look at the left because that's how I start, right? Left to right. And I compare that to the right side. The right side has the x and the x plus 3. So I need an x and an x plus 3 over here. I already have the x plus 3, right? But I need the x. Same process over here, except I need an x plus 4. I really encourage you to multiply these out right away. If you keep this kind of factored like this, it becomes very tempting to try and cancel this x plus 4 with this x plus 4 down here, which is not what you can do. but we like to avoid temptation. And one way of doing that is multiplying it out. When I multiply out a subtraction problem, however, it is easiest to keep the subtraction with this number. So this is actually going to end up being minus 5x and minus 20. I have to subtract the whole numerator anyway, and so if you write it like this, it's hard to remember to subtract both of those. A lot of times people just end up with minus 5x plus 20, which is wrong. You have to subtract the whole thing. So the easiest way to do that is just distribute it through when you do the multiplication. Again, I would look for this to factor, this numerator, once I've combined it together. I don't think that factors. So I just leave it. Questions? All right, so sort of finishing out our kind of rules or strategies is when you see add and subtract, we're going to find the common denominators, then we're going to combine and simplify. I'm just kind of putting that a little blue emphasis there because that's like a unique thing to adding and subtracting. You do not want to get involved with common denominators if you're multiplying or dividing. And that is definitely something I see sometimes. They're not needed and they make the problem sort of not work when you have those. So that's only when you are adding and subtracting do you need to worry about and create common denominators. Questions? Okay. So we have one more major type here. And really at the moment, I would say we're only actually operating with two main types so far. We have this adding or subtracting version. And then we have the simplifying, multiplying, dividing, which are all basically factoring and canceling. And then we have this adding and subtracting, which is this common denominator part. The last type of problem that you'll see are equations. And this, finally, if you were waiting from the first question we had in class, this is that question. Not actually that question, but it was an equation that we were trying to solve. Let's try 2 over x squared plus 9 minus 3 over x plus 3 equals 4 over 5x minus 15. It's not the easiest, but not the hardest type either. I won't ask you the question again because I feel confident you guys are going to answer all in unison the right answer. Just how do you start the problem? And you're all going to say factoring, right? Because you've remembered rule number one and you're recognizing these are rational expressions. So it is correct. I am going to factor. Oh, sorry. I wrote x plus 9. I shouldn't do that. Make that x minus 9 so it factors. Okay, now a lot of students will go into this and think, there's some subtraction here, so I want to create common denominators and subtract these and get that answer. That's not incorrect in that the work you do, if you do it right, will still keep the equation the same. But it turns out it's kind of unnecessary work, and it doesn't usually end up leading us where we want to go. What we really want to do here is I have an equation that has denominators. I don't want those denominators. And because I have an equation, I don't have to keep things balanced by doing the same thing to the top and bottom like I did in the last problem. I can keep things balanced by multiplying the tops here and the tops here. I can multiply left and right sides by the same things. And what I want to multiply by is this least common denominator. So I'm going to have a 5 and an x minus 3 and an x plus 3. And I see this thing is the least common multiple of these three denominators. It's what's going to cancel actually each of these denominators. If I'm doing it on the left side, I have to do it on the right side as well. This is a different problem. We have different techniques and we have different abilities because it's an equation. If it's just this addition or subtraction problem here on the left side, then I can't just multiply the top. I have to do the same thing to the top and the bottom, and it becomes a very different problem. But when I have an equation, I can multiply everything through. I'm gonna have to distribute to both of these terms. So what I like to do is actually just write it in kind of right in the beginning. Like I'm gonna have to distribute it anyway, so I might as well just write it there. Multiply all three of these terms by the same thing. What I'm doing here is I'm going to clear the denominators. I'm just going to get rid of them. These things, because one's on the top and one's on the bottom, they're going to cancel. I'm just going to get 5 times 2, which is 10. Here the x plus 3's cancel. And here the 5 and the x minus 3's cancel. What we're doing is we're taking what is kind of a miserable looking equation with fractions and variables, and we're turning it into a much better equation. Okay, this is, in this case, this turns out to be a linear equation. That's minus 15x plus 45 minus 15 times minus 3 equals 4x plus 12. If I add that over, 55 equals 19x plus 12. Subtract the 12. Divide by 19. this is a really different kind of problem. But sometimes when we look at it, we don't notice that or see that, and we try and treat it like one of our old types of problems, an adding problem or a division problem or something. It's not. It's an equation. It's easy to see if you look for it. I mean, it's got the equal sign in there, but then you have to recognize, okay, I'm trying to do something different with this one. And with equations, what we're trying to do is we are trying to cancel the denominators, then solve. So that is our third type of problem and our third type of strategy. Any questions about this last one? So the good thing is we've actually gotten through most of the section. The only problems that are left are there's some application problems that involve radicals. But all the other sections we've actually covered. The sort of bad news is we've covered them kind of briefly, right? We haven't done a lot of examples from each section. But again, my goal there is so that we kind of see all the different types in the beginning, so that as we're working through the sections, we are conscious that this is not the only way to do it. It is a way to solve this type of problem, right? And when we move to the next type of problems, we'll then be practicing a different type, right, to solve that other type of problem. And the three main types, what I like to group them together is if you're asked to simplify, multiply, or divide, those questions are really just factor and cancel. I mean, you have to flip it if you're dividing, right? But I am confident you guys can remember that part. Other than that, those are really the same kinds of problems. If you have an add and subtract, that's where we have to create the common denominator. Then add or subtract and simplify. And again, it's a different process. You're trying to do different things. You're still factoring, but you're doing different things with them. And then finally, what we have here is with equations. That's a third strategy, right? We're going to cancel the denominators, and then we're going to solve what's left. Okay, so if you can keep those three things in order and do the right strategy with the right problem, you're going to be in pretty good shape. There are still chances to make small errors, right? But you are you're more likely than not to get those problems correct if you can do the right strategies. And of course, always start by factoring. Okay, so this is about kind of generating good habits. Sometimes our intuition or our natural habits with these are not always correct. And so we have to do some work to establish these correct habits. Okay, any last questions? I feel like maybe I blew you guys away somehow, right, with some of these last examples. I hope not. But it did get quiet. Okay. Well, that's got us to around our normal stop time here. So as always, my encouragement is to make sure you are started and making progress on the homework. If you haven't, it's certainly not too late, but if you wait a couple days, all of a sudden it starts to become pretty late, right? So start now so you can start to kind of absorb these ideas over a period of several days. It's going to be really nice this weekend, so you're going to want to be outside. So start now, right? So that you have a chance to do that, hopefully. Okay, I'll let you go. As always, I will post this recording to D2L afterwards, so you can look back at it for any reference that you need to. Remember these strategies and factoring, and I'm confident you'll do great. Okay, so take care. Thank you all for coming. I'll see you in a week and hopefully hear from you sooner.